few words about myself. I'm Ricardo Biasini, and I'm Chief System Architect at comma.ai. I joined Comma in 2016, and prior to work at Comma, I worked for about 5 years at Tesla. I was working on electric powertrain technology, and then in autopilot. And before that, I did some research at the State University for about 1 year on electric vehicles. I think a good way to start talking about self-driving cars is to introduce them by the levels. The society, the SAE divides self-driving cars into 5 different levels. So the first level is level 1. What is level 1? Well, it's what we can buy today. Pretty much every new car that we buy is considered level 1. The human is fully in control of the car, and the car provides some driver assistant features. So for example, it can provide adaptive cruise control, so something that maintains the distance with the car in front, automatic emergency braking, and lane keep assist that allows you to go back in the lane if the car detects that, for example, you are distracted and you are departing the lane. But the point is you are fully in control of the car and you're constantly interacting with the car. The next level is called level 2. Probably the most notable example of level 2 system is the Tesla autopilot. And here the behavior of the car is completely different. The car is now fully in control of driving, and the driver, when the system is activated, a system watches that the car is actually doing the right thing. So it's different. We go from car driving to from the driver being fully in control to the car being controlled and the driver assisting the car. The next step is level 3. I demarked the transition to level 3 with like a vertical line, because here the paradigm change. Like the main difference is that the liability goes from being from the driver, from level 1 and level 2, no matter what happens, the driver is responsible for driving. From level 3 and above, the car is actually takes the responsibility whenever the self-driving features are active. So what level 3 allows the driver to do is allows the driver to be distracted, does not require the driver to be ready to take over immediately, and it works in limited environment, and it always guarantees few seconds of safety operation, even when the system detects like a situation that cannot handle. So imagine that you're driving, you are like reading a book or reading your email, the car detects something that cannot handle, then it's gonna beep at you and it's gonna still perform safe operation for maybe 5 to 8 seconds. That's what is considered like a good transition time. And then you have to take control. The next step is level 4. I think that a good example like of level 4 cars is what we see deployed from Waymo, or like there are many other companies, Zoox or Cruise, GM. They're all working on level 4. So what level 4 is, well, it's taking the driver out of the loop. Like, let's take the driver completely out of the car, and let's have like a driverless vehicle working in limited environment. The next example, the next level is called level 5. Level 5 is the evolution of level 4. It's like level 4, but instead of working in limited environment, it's supposed to work everywhere at any time without a human. So it needs to work at least as good as human everywhere. I personally believe that it makes sense, like the 2 levels that are interesting where people are working on are either level 2 or level 4, and those are the ones that we should pay close attention in the evolution of their technology. So why do I say that like level 2 and level 4 are the most important one? Well, let's look at the numbers. Let's look at how many cars, like what are the distribution of the levels on the cars today on the market in the United States. 87.2% of cars deployed like that we see on the road today are level 0. So they have no assistance. If you look around, pretty much like 6 out of 7 cars that you see, I have no assistance at all. Then there is about like 12% of cars that have level 1, so they have limited assistance. Pretty much all the new cars go into this category. And then there is about like a 0.2% of cars that are considered level 2. I would say those 0.2% is like in large portion made by Tesla autopilots, and like in less less extent from like Cruise GM and few other examples that are popping up from automakers. So why do I say that, for example, like level 3 is not so interesting, and I don't see level 3 being the next evolution, like the next step towards like a driverless future? Well, because level 3 by definition needs to guarantee a few seconds of automated driving when it encounters a situation that it cannot handle. Doing that is not easy at all. Imagine that the system, like it's driving at highway at 70 miles per hour, like maybe 70, 75, and it encounters a situation that does not know how to handle. Well, doing safe operation for 5 seconds means that you travel pretty much like more than a football field during those time. And so, yeah, keep the car doing something safe. It's pretty much as hard as solving for level 4, even if you only have to guarantee those few seconds when the car encounters a situation that it cannot handle. Well, you can say, well, yeah, but it's true what you're saying, but there is one car that actually shipped on the market that has level 3. And it's true. It's called the A8. It's the Audi A8. It did not ship in US for regulatory reasons, but let's look at the limitation of such system. So you need to be on a multi-lane road. You have to have barrier between lanes, so pretty much like on a high-speed highway. You need to have structure along the edge to make sure that there are no pedestrians. Your speed needs to be lower than 37 miles per hour, and the speed of the surrounding vehicles is also low. So this is almost impossible situation to meet, and it's not what level 3 is supposed to be. It's just like an extension of level 2. If something goes wrong in this situation, nothing bad can really happen, and so yes, the car can take like liability for the situation. It does not scale to situation requiring faster reaction time. If you're driving in highway at high speed, you need to be able to handle the situation, and probably you need like level 4 technology. So what about level 4? Level 4 is interesting. It's an interesting technical challenge. There are a lot of companies working on it, but what is level 4? What does level 4 try to solve? Well, let's think about it. What is the definition of like level 4? So like we have level 4 cars. How do they work? Well, the idea is that they allow you to go from point A to point B without requiring you to drive. And if you think about it, this already exists. Like there are taxi, there are Uber, I can use public transportation. So they're trying to replace a service that already exists. It's not going to be more practical. It's not going to be more practical than Uber. It's not going to be more practical in certain cases than public transportation. If you live in Manhattan and you want to go from point A to point B, probably taking the metro is the best way to do it. So what's the advantage of level 4? Well, the advantage is the idea that they're going to cost less. Why? Because the idea is to remove the driver and to remove the cost of the driver, which I personally have some doubt. Like when you pay a Uber Drive, it's not a big portion of your fare that goes to the driver. The big majority pays for the car maintenance, car insurance, gas, and the fees to Uber. So level 4, by definition, since it's not supposed to drive anywhere, anytime, does not compete with car ownership. It's not meant to end the car ownership. This idea that when level 4 succeeds, the people will stop owning cars is just not what level 4 is going to give us. And it's also like very unclear how long such a service will take to be better of Uber, Lyft, public transportation in terms of cost and practicality. So what about level 5? Like I said, when I showed the slide before about the levels, I didn't show any example of companies working on level 5 because literally nobody is working right now on level 5. It's a very hard problem. Those are two famous quotes that I usually put in my presentation. One is from Elon. In 2016, he said that in about 2 years, someone, which is the function that is supposed to call your car out of your garage that is working, you press a button and the car like slowly crawl out of your garage. Well, he was predicting that in 2016 and in about 2 years, so 2018, the car was able to have this function working from New York to LA, for example. So he was imagining a future in 2018 where a car could drive completely without human intervention, without a driver in the seat, from New York to LA. And another quote is from Chris Armstrong. He was like the ex-chief of the self-driving program at Google before he became Waymo. And he was expecting that his son, which was 12, was not going to need a driver license by the time that he was going to be 16. That was in 2015. His son was 12. Now I'm pretty sure he's more than 16 years old. And I'm pretty sure he got his driver license. Why it's actually like hard to solve for level 5 and nobody's working on it? Well, it's a very challenging problem. You have to solve for situations that are very hard to train a system for, and humans are very good at it because they actually use like things that they have learned outside driving. The first time that I drove a car myself, I did okay. How come if I never drove a car? Well, I did okay because I was actually transferring the learning that I did outside driving to driving itself. So how much of driving is actually using skills that have nothing to do with driving? It's possible that to be able to replace the driver entirely in any situation, you might need some sort of like artificial general intelligence systems being developed first. And so this is something that is definitely going to take a while, and I don't see it being like in a close horizon. So why level 2 then? Well, so what's interesting about level 2 is people spend 5% of the awake time driving, and while you drive, you pretty much take one action of correcting the gas, correcting the brake, or correcting the steer pretty much every second. So if you drive for about like 3 hours straight, that's about 10,000 single intervention that you have to make to your car. And that's relatively stressful. Another thing that is worth noticing is that there have been last year 37 fatal accidents in the US. That's an increase of 15% from the minimum reached in 2014. This is like quite interesting because, and unfortunate because for many decades, fatal accidents in the US have been going down. The reason why it has been going up since 2014 is that people are more distracted while driving. They look more at their phone. And unfortunately, this made more fatal accidents. And so there is really the need of making sure that there's a system monitoring the driver, paying attention. I'm not sure why it goes. So another very important thing to note is, and this is great, is that all level 1 cars sold today, so pretty much every new car sold today, already have the hardware to be a level 2 system, to have level 2 system. Like if you think about level 1 cars, since they are capable of maintaining distance with the car in front of you, are able to steer you back in the lane if you are about to depart the lane, it means that they have ways of controlling the gas, the brake, and the steer. And so those actuators can actually be controlled in a better way, not only to provide level 1 features, but actually level 2 features. The reason why cars that we see on the market today have only level 1 features and not level 2, in my opinion, is because of cars are developed with a very long development process. It's not possible to make over-the-air update in pretty much like every car on the market today, except for Tesla. And the car, like the hardware that makes your chassis, like your actuators, is very integrated with the hardware that makes your computing and the software that comes with the car. And if you think about the lifespan of a car, the average lifespan of a car is 15 years. Think about how much like computing and computers have changed in 15 years. So I do believe there is this need to decouple the hardware of the cars, like what's the chassis and what's your actuators and what makes the hardware for your car from your computing hardware, which is what actually makes your driver assistance features. So in order to describe what level 2 is, we can just look at the video. This is our system that we developed at comma.ai. It's, you can see the system itself, like the hardware is mounted on the windshield. It connects with the CAN, which is the communication system of the car. And this is retrofitting a level 1 car, which is a 2016 on the Civic. So how does a level 2 system work? Well, so the idea is that you press a button, you engage, and then the car handles driving for you. You have to pay attention, but the car will keep you in the lane, will slow down, will accelerate depending on traffic conditions and all other information that it can gather from the environment. So it's a very different way of driving. Of course, as the system gets better, it's very important that the driver keeps paying attention. And so every level 2 system, as the level 2 system gets better, it's very important to monitor the driver. And so in our system, this is done by a camera that is also watching the driver. So there are 2 cameras, one looking at the road and one watching the driver. So how does driver monitoring works? So the idea is that the camera is watching you. And so if you, for example, while driving, you're being distracted, so you're looking away from the road, or for example, you're falling asleep, or anything that the system detects that you are not looking straight, then the system is going to start to alert you, it's going to start to beep at you, and then eventually, if you don't take control, the system goes into a mode where it's going to force you to disengage the automated feature, and it's going to slowly bring down the car to a safe stop. So how does self-driving car work? So before introducing and talking about data, let's spend a few words about how an architecture of self-driving car is. Well, you might have seen this before. It's a very standard kind of layout of the system working in a self-driving car, but more in general in many robotics systems. So you have an initial, your input comes from your sensors. You use sensors to sense the world. In self-driving cars, those sensors are typically cameras, LiDARs, radar, ultrasonic sensors, and all the sensors that you use to perceive the state of the car itself, like accelerometers, gyroscope, and magnetometer, GPS to understand your positions. And so once you have the data from this sensor, what do you use them for? Well, 2 things. One is you localize yourself. You localize yourself in the world reference. This is very important because, well, if you are working towards a system where the car drives itself, it needs to be aware of your position to better drive you while the system is active. And it also uses the input from the sensor to make a semantic representation of the environment. You go from a dense sensor output, for example, for cameras, you have these million of pixels in RGB format, so it's very dense, it's very high dimensional output, to something that you compress and you extract information that then you need, that people know how to interpret, and then you need to keep going with your flow of operation. So to make some example, in self-driving cars, usually the perception layer determines where lane lines are, where cars are, and where all the various obstacles on the road are. So then you use this input to your next block, which is called planning. So once I know where obstacles are, I understand my environment in a semantic way, then I can plan for it. I can generate a trajectory that I want the car to take. Once I have the trajectory, I actually have one last block, which is called controls. And it's the block that actuates the car, physically actuates the car to make sure that the car follows your plan. Good news about the current state of self-driving cars on sensor and localization. This is already at superhuman level. You can put as many cameras and as many sensors you want around the car. You can have at any given instant a perfect 360 view of your surrounding. Humans, of course, have to turn their head and they have to sacrifice some field of view while they're looking around. In self-driving cars, this is not necessary. You can put as many sensors as you want. And localization is also superhuman. For example, last year, we drove around a closed track without using any vision input, just by using our GPS and doing a sensor fusion with the sensor on the car, like accelerometer and gyroscope, and we were able to continuously loop around the track without having any sensor, and we had, I would say, probably a precision of less than 1 meter, less than 3 feet in placing, in understanding where the car is in world reference. This is already superhuman. Humans, of course, don't understand where they are in world reference with such accuracy. Controls are good enough. They're definitely better than human when they work in their specific domain of operation where they've been developed for. They don't work, or like they're a little bit trickier to have them work as good as human when the condition suddenly change. So imagine that you're driving and all of a sudden you hit a bump, or your steering gets misaligned. Well, then you have to have an algorithm to understand that for you driving straight means applying a little steering on the side. Well, so this is, you have a lot of those situations that you need to handle, and handling all this situation is a bit trickier, and I think human can do this currently better than machines, so adapting to sudden change of your model. But I think controls are definitely like pros and cons with respect to human, and they are good enough. It's now what's holding back self-driving cars. The things that are like highly subhuman, human do better than machines, is sensor fusion and perception and planning. Sensor fusion and perception, like understanding the semantic representation of the world, human are better at it. Typical examples, there is a long tail of events where self-driving cars have a little bit hard time handling them. So imagine like you see a plastic bag tumbling on the road. Well, self-driving car might recognize that there is like an obstacle, but then you have to decide, is this something that I can eat, or is this something that I should brake for? And this decision becomes very important if you're driving at 65, 70 miles per hour down the highway. Planning is also very hard. The way that humans think, like plan their trajectory, I personally believe, as I was saying before, it has more to do with skills that not necessarily people have learned from driving, but things that they just understand. They have some sort of like intuition about the physics of the world that they just apply, and they generate those trajectories, and it's very hard creating algorithms that generate trajectories. So maybe a better approach, which is what we are pursuing at Comma, is putting together and try to solve at once sensor fusion, perception, and planning, all some sort of like more like an end-to-end approach. And we think this is going to scale better than trying to separate these two blocks. So what are data useful for? Well, data are useful for improving those two blocks, because they do need machine learning, and machine learning can work with data. So let's talk about data. Why are data important in self-driving cars? Well, of course, first thing is to train neural networks. You collect your data from your devices, from your fleet, and then based on the behavior, the correct behavior that the car took on the road, you try to train neural networks that understand how to drive as they got from the example of driving. Another thing why data is important is that you can use data to build your own HD maps. This is an example of the maps that we started to build based on our data. You can, in this case, we generated a cloud point data set that, for example, described the Bay Bridge in the Bay Area. And this is important because having these informations helps you localizing very precisely in word reference when you're driving. Data is also useful to simulate and debug. When you collect back data from your fleet, you can use this data to see what happened. And you can resimulate the data. You can use, I mean, this is one of our debugging tool. And you can actually replay part of your code on the data that you collected to see how, for example, some changes of your code will affect part of the data, part of the output that was actually collected. And then, of course, you want to collect data in case of self-driving cars. Eventually, to offer a service to your users. The product that we sell is called the comma.ai. It's the device that I showed before in the video, and it also works as a smart dash cam. So you have cameras, you can collect data to the cameras, and then, of course, like the user can have access to their own data. And we built our own like Explorer, so if you are like a comma.ai user, then you can go on explorer.comma.ai and review your drive and everything that happened. So one thing that's important to talk about is also the cost about data collection, because we talk about the benefits, and someone might have the idea or like the impression that more data is better. Well, you have to consider also that there are costs associated to data, and it's not always true that more data is better. I think a good plot is the one on the right, which separates between companies that have a product in the field, and they can collect their data through the product that they sold, versus companies that actually have to make their own fleet and they have to pay in order to collect data. I mean, if you think about how much a Tesla costs, how much like individual profit maybe Tesla can make on each car, and you work out the math, I believe that Tesla makes money for each mile that they collect, because it means that they sell more cars. And I would say like same way is true for us. The more miles we collect, it means the more devices we have sold. This is definitely not true for companies that are working on level 4. They have to make their own cars, they have to make their own devices, and they have to pay drivers, at least one, in some cases even two, that at any given time drives car around, and you have to pay basically for their salary. And so if you think about the math, how much you pay each driver, well, it costs to level 4 companies about, I like estimate, these are my estimates. I estimate that they pay about $2.5 per miles. If you think that companies like Waymo connect pretty much the same amount of miles that we collect, I believe it's around several tens of thousands of miles each day. Well, if they pay $2.5 multiplied by, let's say, 30,000 miles, that's about $70,000 per day. That throughout a year, that's like about like $21 million. And yeah, the budget, you have to have deep pocket if you are owning like a level 4 fleet and you are collecting data through your own fleet. Another thing that you have to consider is like connectivity in cost. You have these devices that collect your data. How do you get data back? Well, if you own your fleet, this might be a little easier because the car gets back, and you basically can stream back the data using like physical connection. But for our distributed devices, yeah, we can use Wi-Fi, but it's very convenient for users if can actually upload their data through cellular connection. Cellular connection has a cost, and so these must be considered when you stream back data to your database, to your data center. Another thing that has cost, if you use data for training in machine learning, you have to label them. And the label is something that is generally done by humans. So you have to teach what's right to your neural network. And so you do this by having like, it's usually done by having like humans like taking a picture and telling and like taking notes in where in the picture things are, what everything in the picture is. In this case, where cars are, where roads are, lane lines, buildings, etc. We at Comma move completely away from human labeling, and we try to do everything automated. So we use neural networks to label data that we use to train other neural networks. Another thing that like that you pay for is, of course, processing, training, and data transfer. If you have your data stored on the cloud, on your like local data center, you do spend on data on like processing your data. You do spend electricity to train your data because they run on GPUs, and you do spend also data for data transfer. If you have your data on the cloud, you have to transfer your data to something local eventually if you want to train locally, and this also has a cost. And probably the most important thing is the cost of storage the data. One thing that at Comma we quickly realized is as the number of users that we have keeps growing, we saw that a really like steep increase in storage cost. If you think about it, and if you assume that the number of users that you have is some sort of like growing linearly over time, well, think about how much storing their data indefinitely is going to cost you. I mean, generally, if your function of user increase is called f of x, where x is your time, well, the cost of storing their data is the integral of f of x, because you have to store all their data, old data and new data over time. And so no matter what your business model is, in the case of self-driving cars where data are particularly expensive, because in our case, every hour of driving is between 5 and 10 gigabytes, In the case of level 4 cars, I would not be surprised if every hour of data is going to be hundreds of gigabytes. Well, you're going to quickly start to skyrocket your cost of storage if you don't act on it and you start to delete all data as your user base actually grows. So some tips about data storage and use of data. I think unless you have, as I said before, a lot of money, people have invested a lot of money on you, and you can build your own fleet, and you can afford of paying tens of millions of dollars per year in data collection. Think about making a sustainable business model around collecting data early on in your stage. So in case of Comma, the first product that we actually released was a dashcam app. You could download from the App Store or from the Google Store, Google Play. You could download our app, which was called Schiffer, and it's a dashcam app. And through that app, we were collecting data. The app was free, but at least we didn't have to pay for every data that we collected. The second product that we released was Can Reader. It's an OBD2 dongle. It's called Panda. And this is the first time that we started to make a profit with a product. So by syncing your app with the Can Reader, not only we had back vision, camera data from the car, from your phone, but also we were able to sync the data with your Can, with all the data that was running onto your communication area network, which is the protocol of communication of your car. And this was great because we could sync everything that was being recorded from the sensor of the car together with the video data coming from your phone. And then we evolved into the product that we are currently selling, which is called the comma.ai. It's a smart dash cam. It's something that you can install on the windshield of your car. By default, it provides passive driver assistance features, and with passive I mean warnings. So it detects if you are distracted, it warns you if you're about to collide, and then of course it provides all the functionality of a dash cam. But at the same time, it's also a completely open development platform, which can be coupled with our open source software, which is called OpenPilot. And so it does support OpenPilot. And OpenPilot is the software that I showed you before in the video that can actually drive your car. Another thing that you might want to consider about data is think if the cloud service is worth it. Is it worth storing your data on the cloud? It's definitely a good starting point. This is where we started as Comma. We started to upload all our data on the cloud. Also, cloud services, companies that provide cloud services, are very good in giving you some sort of a intro grant where you basically use their service for free up to a certain amount of expenses. And this is a great starting point. But then as your user grows, if you really don't have a backup plan or a way to contain your cost, you'll find yourself, once you run out of the free money provided by the cloud service, that you are going to spend after that a very high monthly cost because, as I said, your user growth is growing quickly. And so consider that keeping your data on the cloud is actually a good thing, especially if you use your data for training and you want to set up an easy infrastructure to transfer data around, maybe actually transfer it locally is a good solution. And we definitely thought it was a good solution for us. We did the math. Buying our hard drives allows us to repay the cost of the cloud in about 2 months. Of course, we don't have the same redundancy that we have on the cloud, but at the same time, as I said before, our users keeps growing, and so for us, there is not much value in today's data. There is more value in the ability of collecting new data. Select and upload only the data that you need. Currently at Comma, we are uploading all the data from users, but we'll soon start to think about, well, maybe not all the data are so relevant. Most of the data about driving is somewhat boring. It's about driving straight on the highway, and after you have enough data of this, maybe you don't need any more data, and instead you can select your own data based on certain criteria that you define at any given time. It could be, for example, any time that the user intervened, any time that the user corrected the action of your system. It's very interesting data because it means that somewhat your system failed to do something right. And so that's useful data, or maybe like turns, or maybe adverse climate conditions, etc. And ultimately, this is for some psychological reasons, companies tend to keep around data that they don't use. My recommendation is discard data that you don't use. As you progress in your hardware, you'll have legacy data. Legacy data means data that you are not using. It's incompatible with newer data. And so instead of keeping it around and thinking maybe I will find a use of them in the future, think about that you are paying constantly a monthly fee for them, and maybe like a better idea is discard data that you don't use. Don't keep data around if you don't have a good use for them at any given time. Thank you. Yeah.
We have a minute for a couple questions.
Yes. Yeah, definitely. I think level 5 cars, I don't think there is a need to call them level 6. I think level 5 cars will actually be very similar to what you described when they're going to be deployed. I think a lot of it will be around like entertaining. It's pretty much like flying, like the idea of giving entertainment to the driver. I mean, we start to see maybe, I mean, we see a little bit of this like in cabs, when you take a taxi, you have in some taxi, you have like like you can watch a video in front of you. And I definitely see these way more like passenger center, like those like level 5 vehicles being deployed in this way. I don't know, like, yeah, it's going to be interesting. I think the first deployment of level 4 is probably going to be retrofitting existing cars. Building new cars is very hard. Getting like the good reliability is hard, and it's a lot easier to retrofit existing models with the hardware and the sensor that you need. But then, as like the technology progresses, then I do believe that cars are going to be optimized around the customer experience. Definitely. I think we're out of time. Okay.
Well, thank you very much.
Thank you.
Are you going to be around for a bit?
Definitely. Yes.
Okay.